Hi there, welcome to today's lesson. Today's lesson is titled, What is Engineering? We're going to talk briefly about what engineering is and kind of set the stage for the program to follow. Now, we've got to first about engineering in general. First off, you need to understand, engineers produce things that affect us every day. They invent, design, develop, manufacture, test, sell, and service products and services that improve people's lives. Engineering is that practical application of science and math to solve problems. It's everywhere in the world around you. Engineering technologies improve the ways that we communicate, work, travel, stay healthy, and entertain ourselves. They're problem solvers who want to make things work more efficiently and quickly and less expensively. From computer chips and satellites to medical devices and renewable energy technologies, engineering makes our life. Now, you've got to understand, that brings in, well, what are we looking for from an engineer if these are the things that they're doing? Well, Boeing came up with a list of basic, durable attributes that can be referenced to a specific skill reflecting all the various aspects of the engineering profession. First off, you have to have a good understanding of engineering science fundamentals, mathematics, including statistics. That's, trends, figuring out how things work and which way is it going. Is this a good idea or a bad idea? Physical and life sciences and information technology. That's a lot more than just computer literacy. It's more than just being able to use Microsoft Word and PowerPoint. You've got to use computer-aided engineering, things like SolidWorks and MATLAB, LabVIEW, all these different things that go into making an engineer better. You also have to understand the design and manufacturing process. You have to understand everything around engineering and how that works. And you have to have a holistic overview, big picture view of everything, a multidisciplinary perspective of how everything fits together. And you have to understand the basic context in which your engineering is being practiced. The economics of it, business, is it good for business or not? The history, what's gone on before, what's been tried before and what's happened. The environment and what kind of impact will your engineering have on the environment. You also have to understand customer and societal needs. Engineers have to be good communicators. They have to have good written, oral, graphic, and listening skills. They also have to be highly ethical because what we do could be potentially dangerous and we're held to a higher standard. Engineers have to have the ability to think both critically and creatively. They have to be independent and work cooperatively. And thinking creatively and critically in a group is difficult, and it takes time and practice to get that down. They also have to be flexible. You have to be able to adapt to rapid and major changes. Things are always happening, and you have to be able to adjust to it. And engineers need to be curious. They have to learn for life because engineering and technology is always changing. The world is always improving and growing faster and faster, and we have to be able to keep learning so that we can stay up with it. And then engineers have to really understand the importance of teamwork because you don't work by yourself. You're not in a cubicle working by yourself only for you. You're in a group. It's a team dynamic, and you have to understand that. And now you can find this list on Boeing's website if you wanted to look it up later for yourself, and it's also some of it's on the ABET website. But that gets into what an engineer should be able to do. So what should they be able to do? Well, engineers need to be able to determine quickly how things work. They also need to be able to determine what a customer wants. They have to be able to create a concept. They have to use abstractions and math models to improve that concept. Then they need to be able to build and create a prototype version and then test that version to make sure that it works and predict how it's going to perform. They also have to determine whether or not what the customer wants and what the market wants are aligned together. They have to have some business sense. Is this a good idea that we're doing? And then they have to be able to communicate all of this to various people, whether it's another engineer or it's a city leader or it's a customer. They're going to have to be able to communicate it. Now, a lot of this stuff requires very specific knowledge and experience and depends on what you're doing. And several of the items require you to be able to think in a broad picture. But all of them require teamwork, leadership, and societal awareness. So, engineers design. And that begs the question, what is design? Well, design is that process of going from specific needs to a product that meets those needs. Now, this is our first introduction to what's called a black box model. We don't see what's going on in there in the design process, but we do know that what the inputs and the outputs are. Coming into that design process are the customer needs and requirements, and also some math, physics, and engineering, and we jumble it all together, do some stuff to it, and out comes our final product. And that's basically what design is. You take in your needs and requirements, you apply math and physics to it, and you get a product. We're going to take a close look at that and look at something going on. We're going to look at an actual product design development. And we're going to see the development of a Swiss prototype for an F-18 Hornet. Now, they wanted to develop a low-drag pylon. They were having problems. As they put bomb payloads underneath the wings of the airplane, it would really create a lot of drag and really hamper the performance of the airplane. So they wanted to come up with a new pylon underneath, and you can see where it's fitting in this new Swiss drag pylon. As they developed and designed it, they found out that they had a 20% improvement in the performance of the airplane. That's what engineers do, and that's the basics of design. So we're going to look at the process of design and give a broad spectrum overview. Now, it's a lot more detailed than what I'm giving you. We'll go into that detail later, but right now I just want to kind of give you a brief overview. Well, the first thing is, in the design process, you've got to understand the important aspects of design. It's got to be useful, meet your customer's needs, and it has to be safe. You also have to be able to measure your product in your design. Things like cost, quality, time. Customers and management, they always want it cheaper, better, faster, and those are the things that go into it. Those are things you can measure. And then, now, whatever your design is, whatever's going on, this whole process, the roadmap is still the same. The output may be different, the inputs may be different, but that roadmap, that process inside of it, the design, it's always pretty much the same. So the individual steps in the design process, let's look at those. Well, first off, you're going to establish a need. Do you really need this? If you don't do it. Then you need to understand what the problem is, what's going on underneath. You're going to generate some potential solutions. Then you're going to evaluate them. Are they really good or not? Which ones are good? And then you're going to come up with detailed design, and you're going to document this. Next, we're going to actually test the ultimate design. We're going to evaluate what's going on. And when it comes up with a good design, we're going to give a final product and design that meets our customer needs. Now, if anything, anywhere along the way, we can reiterate. If the customer's not happy, we can go back and rework it. That's called iteration. Finally, we're going to send it out and test it in the markets. Now, for a design to work, it has to be cost effective and it has to be safe for people to use. If anywhere along the way you're having problems, you can always go back and redo it and rework it. And that's the heart of the engineering process, is that anywhere along the way, if things are going wrong, you go back and you rework it and you keep reworking it until it's done and until it's done correctly. And that's the great thing about engineering, is that you get to keep redoing it until it works well. And that's what we really like about it. Now, I want to talk a little bit about engineers. You know, we've talked about how they work, and engineers, they're never satisfied. They're always looking for things to be better. A case in point, used to, people will go hunting with knives. Knives were a big part of life, and especially before guns, but even so nowadays. Well, knives can be dangerous. You can't really carry it around in your pocket without stabbing yourself in the leg. We wanted to come up with some way to be able to carry a knife and not stab ourselves. We want to be able to put it in our pocket and feel safe doing that. Well, along came the Swiss Army knife. We're all familiar with that. We've got a knife on there, a file, there's some tweezers, and a bottle opener. It's a pretty handy little tool. It's really compact. It's very convenient. It serves our purpose. It did exactly what we wanted it to do. But engineers are never satisfied. They wanted more. They came up with this one. This thing has everything but the kitchen sink on it. You've got corkscrews, you've got a couple of different knives and scissors, a couple of different scissors, a magnifying glass, a pencil. You've got all kinds of stuff that aren't even knives on there, including your knives. So this is it. This is everything. No, not quite. Engineers are not satisfied. They wanted more. This thing doesn't even have a knife on it. You've got a light, you've got a USB drive, but no knife. This is the heart of engineering. You start off with where you're at, and you keep making it better, you keep improving it, you come up with new things, and this is where you get innovative, and this is what really makes America great, is because we're able to innovate and come up with new and better ideas and keep working at it. And this is what engineers do, and this is what makes engineering great. Now, finally, we're going to watch a short video. You're going to find the video in the same folder with this presentation. It's the John Deere video. I want you to watch it and see how the engineers at John Deere use that engineering process and use some of the engineering tools to make their products better. So I hope you get a brief look at what engineering is. We're going to go into it in a lot greater detail throughout the year, but I wanted to kind of give you a brief overview and kind of set the stage for what we're doing.